You starting?
Yeah.
Okay. Alright. So, hi and welcome everyone. This is the first lecture. Well, I guess I would call this lecture 0 of the course. So this is the course 310H, which is honors data structures and algorithms. For this course, I will be mainly so the main of this course or the main instruction method of this course will be in person. But for those of you that want to be remotely connected to the course or looking at taking the course from different location, recording will be available after each classes, and then and I'll upload the video and I'll upload the Zoom the link of the video to YouTube. I will also make the class live use over the Zoom, which I already sent the link to the course. But then anyway, so I will make, if you have any concern or questions, let me know. I will try to make this course accessible to as many people as possible using either like online methods or either in-person methods. So just going back to the topics. So today I want to talk about some introduction and the overview of the structure of the course. So again, this is a CSE 310H. This class on AUME 119 will be the main classroom for a course. If you have any problem not being able to make it, let me know. And send me questions if you have any, or send me an email if you have any questions about the course. So let me go ahead and begin. So there's a few things that I want to talk about today. I want to start off with giving you some motivation of algorithms and data structure, just to motivate you about this class. I know most of you already kind of motivated to take this class to begin with, so I will just give you some additional motivation for this. Then I will tell you about my connections to this class, particularly my background research and how I have some expertise in teaching this course. And then I'll kind of tell you about some of the organizational stuff for the class, particularly the webpage, the syllabus, and the calendar. What we're going to do in this class. And then I'll basically go into some basic stuff about algorithms and data structure. Lastly, if you're in class or if you're watching this video, I will have some in-class exercises. So at that point, when I talk about in-class exercises, you can optionally pause the video and think about the questions before I move on. I will also explicitly say pause so that you can think about some of these exercises before you move on. Usually I will ask people if you have any questions, but we're doing live recording, so I don't have any questions to pick. But if you have any questions, I will be available in my office hour, which is right after this class. Okay, so the first thing is I want to motivate you about why we care about algorithms. So in our everyday life, we kind of encounter different types of scenarios that kind of require us to develop algorithms to tackle some of these challenges or some of the questions you want to answer. So for instance, you might want to look for some car on a car web page. And a lot of the time you can sort them based on different criteria. So maybe you can sort them based on highest price, lowest price, oldest model, newest model, things of that nature, right? So for example, if you're like me, I would like to go online and I will find the cheapest car. So in this case, internally, this web pages use an underlying algorithms to somehow sort the car price based on the information they have. Another example is this finding the shortest path. So imagine that you're trying to go from University of Nebraska Lincoln to the Omaha campus, and you want to figure out what is the shortest path to get there, right? And to achieve this, you can formulate these questions as algorithmic questions, and then you can try to answer these by applying algorithms to find the shortest path. The last examples I have is just matching nucleotide sequences. Imagine that you're given a long sequences of nucleotides, and you want to find subsequence of this nucleotides that matches the longest sequence, right? So they have important applications in biology where you want to find some kind of substrings or subsequences that match these, right? So in this particular examples, a subsequence will be discovery, right? The last one. Okay, so now that we talked about some of the main examples, one question that you should be thinking about at this point is, what is algorithm, right, in this concept? What's an algorithm? Well, think about this before you move on. You can pause here and you can think about some of the definition. But here I'm going to give you a really generic definition that's in the book. I think this is in the chapter on the book that will be a good reading for you to look into. But one of the definitions the book gave us is that an algorithm is a sequence of ambiguous instructions for solving a problem. Right? So in particularly, you have a problem in mind, you have some input and output, and you want to design an algorithm that starts taking the input and produce something, right? That's output. So a lot of the time what you did in the previous classes is that you have a problem in mind, and you try to somehow design an algorithm for solving it, and basically, in order to design an algorithm to solve it, you kind of program into something that can be actionable by the computer, right? So you turn the algorithm usually into something you can code, right? Like for instance, Java, C++, or Python. So in either cases, this is what algorithm looks like. You try to design an algorithm to tackle some problem that you're interested in solving. So in particularly, there are different types of algorithms out there that can solve the same problem, right? In particularly, the analogy here is that there could be more than one way of multiplying two numbers, right? I mean, maybe some of them is more efficient than the other, but that's more the way of solving one particular problem. And in particularly, different algorithms have different trade-offs, as you will see in this class. And you can use different ideas for solving the same problems, or different algorithms will have different types of running times. So it really depends on what you're trying to do when you're designing an algorithm, right? So that's the main message here. Now that I gave you some motivation about the courses, I want to tell you about my background, my research. So I've been working on a lot of these areas that sort of related to applying AI and algorithms to tackle some of the societal problems. In particular, some of my research involved machine learning, game theory, networks, assignment or matching. So all of these projects I work on sort of require you to develop algorithm to solve some particular problems in the domains. So if you're interested in it, you can kind of look at my webpage. So this is my webpage here. You can, if you click on this, you will be able to get to my webpage. I'm just share this. So this is my webpage. So you can look at the description of my research, but a lot of my recent work has to do with design algorithm to solve a particular problem. For instance, some of my recent work sort of design algorithms for solving this optimization problems of take some other function which you don't need to know what it is. We also look at some recent work on how do we design algorithms to fight forest fire when you have some uncertainty about where the fire is going to be and you don't have observation about where the fire is, how large the fire is going to be. We also look at some kind of game theoretical model to understand how people move and how people select where to live based on their personal preferences. So these are some of my work, and all the work that I've done so far requires us to design some on algorithm to tackle some of the problems that we're interested in doing. You can see more of my information on the web page, but also you can also access the classwork page by clicking on this link, which I posted on Canvas as well. But anyway, so I'm happy to talk more about my research if you're interested in learning more. So going back to the PowerPoint, so these are my research, and here's some of my background. So I came to UNL 2 years ago. Before that I was an undergraduate at the College of Charleston, which is a liberal arts college. I did my bachelor degrees in math and computer science. And then I went on to do my PhD in computer science at Stony Brook back in 2015. So Stony Brook is this you know where it is? It's Long Island near it's in the middle of Long Island. Then I did a postdoc at Trinity University, which is a liberal arts college in San Antonio, Texas. And then I did a postdoc at Harvard more recently before I came, back in 2017 to 2019. As I said, I'm interested in doing working on a lot of problems that sort of leverage AI and algorithms for solving social problems. I've been working on applying AI and machine learning to solve problems in homeless youth domains and cybersecurity and physical security domain. I'm also interested in other notions called other areas in mechanism design, applied machine learning, and computation game theory. So more recently, last semester I taught this undergraduate level algorithms and data structure D10H. So this is the second time I'm teaching it. Again, you can see more of my information on my webpage, and I have a group actually, and you can check out the members on my group. So if you have any questions, let me know. I'm happy to answer this. So anyway, now that I told you about my background and some of my connection to the course, I want to tell you about the organizations of the classes, which kind of lead us to the class web page, which you can click here. So there's a few things I want to talk about on my class web page. So if you click on the link, you will get to my class web page. And this has some course description we just talked about. Again, it's something that we discussed earlier. And there's three main things that we want to talk about in this course, including some of the topics we want to cover, some of the algorithmic techniques, some of the data structure, and some of the problems that we're going to be facing, or at least trying to solve while learning some of these techniques. So for instance, some of the techniques we're going to be looking at will consist of complexity notion, which you already know from your early courses, summation, induction, and recursion. So these are something that you probably learn in your discrete math course. If you don't, it's okay. We're gonna review it very briefly, but anyway, so we're gonna cover them a little bit in the first week of the course. And then we're gonna talk about different approaches, including brute force and exhaustion search, divide and conquer, greedy, iteratively implement, dynamic programming. So these are some of the stuff that we're going to learn. Reduction is something that you probably haven't heard before. It's about showing that a problem is particularly hard as far as some problem that may not be able to solve in finite time. And finally, we're going to look at something called approximation algorithm. Basically, it's an algorithm that used to solve a very hard problem, which might not be able to solve in finite times or efficiently unless you approximate it. Right? So these are some of the things we learned. If you don't know the concept, it's okay. We're going to be talking about them anyway in this class. We're going to look at some data structure here. These are important data structure. That's good to know. In particular, we're going to be talking about binary tree, balanced linear tree, ABL tree, B trees, hashing, graph, and heaps. Right? Some of them you know, some of them you don't. It's okay. And the problem consists of something that you might know already, including sorting and searching, closest pair, conventional problem, traversal on graph, topological sort, matrix multiplication, linear program, maximum flow, knapsack. Yeah, there's other problems that we're going to be talking about in this course. When you can click on the syllabus here, if you click on this, and this is basically gave you what the general structure of the course, what it's going to be look like. Again, here's the class logistic information. A class, the time again is Monday, Wednesday, Friday from 12:30 to 1:20 in this classroom, Avery 119. And if you can come in person, it's okay. If you cannot, let me know. I understand. You might have concerns or you might not feeling well that particular day, so let me know. Again, all the video will be available online, and all the lecture and PowerPoint will be uploaded onto Canvas. So you should be able to have all the material available for you to do your assignments. Did I mention my name? I think maybe it's a bit late. So my name is Hao Chen. You can call me Dr. Chen, or you can call me Hao. Either way is okay. And here's my office. My office in Avery 363 is the third floor of Avery, and it passed the double door on your right once you go up. This is my email. So this is my main email. You can contact me if you have any questions. This is the phone I have. I don't know whether this is still in service. I mean, it might work. I don't know. Maybe the best way to reach me is my email instead of calling me. I haven't used this number for a while, and I might or might not be in my office when you call. So the best way to reach me is through my email. My office hour again is right after this course. It might subject to change, depends on further requirements or policy. But it will be done virtually in person. I will try to go to my office. If it's not, then I will be available virtually over Zoom, which you already have the link. For homework, I created a specific homework submission email. So you can email all your homework to this Gmail address. You can also email me directly for any other questions, but this will be the submission site for your homework. There's other submission format that I would like you to do, in particularly labeling your assignments in a particular way and putting your first and last name here. So we can go with that a bit more when you submit your homework assignments. So due to this COVID-19 situation, or I want to make a lot of these online, so I would prefer you send me a PDF of your homework. So some people have done it in the past where they have written the homework in hands and they took like a PDF image, like using the cell phone. But that's an okay option. But I would prefer you to use some kind of medium tools to generate a PDF, namely LaTeX or Overleaf. So you can go in Overleaf, create your account, which is free for everyone, and then you can generate your LaTeX that way. So I would prefer you to do this. Here's some prerequisites. I don't want to go over it too much, but this is some of the requirements for joining this course. I'm sure most of you already have these requirements. Here's more about the course description. You can take a look. I don't want to go over it too much for the sake of time. And then the course objective and learning goals here. Again, the goal here is to make you learn about algorithms and data structure. And particularly the course would be based on textbooks that we have, some of the paper reading, your presentations, homework, exams, and projects, which I will go over a bit more detail later on. And so I guess there's some passing grade here, and the idea is that you should be able to, after this class, you should be able to understand some of the key concepts and basic algorithmic techniques or approaches for solving algorithmic problems. you should be able to understand the connection between data structures and algorithms, meaning how you can use data structure in order to facilitate the running of algorithms or to design better algorithms. You should be able to understand some of the classic code algorithm problems you were studying in the past, and the complexity, how hard they are, and the solution and potential application to solve real-world situation, real-world problems. And finally, the last goal I have is to kind of for you to understand the limitation of computational power. So most of the problem that you have done so far in class usually are solvable efficiently. So there are some classes of problem in which you cannot solve efficiently in real life. So here is trying to get you to understand what you can do using computational power, even you have unlimited of them, or what you can solve using good algorithms. Right. So there's two books. Well, I guess there's one main book I'll be using. So this book I have used it last year, and it feels it seemed to be pretty reasonable for many of the students for my course in the past. So this is the main textbook we're going to use. It's available online. You should be able to find it online. And this is consistent with other textbook that other instructors use in regular boot camp course. This is the second book. I will use it sometime throughout the semester, mainly chapter 9, and we'll use it in sometime in October, not in November, since our semester is restricted. So I would kind of recommend you this book if you're interested in working at Google or Facebook, because I think this book has a lot of good questions that address some of the interview questions that they ask. So it'd be good if you're interested. You should get it. And again, all of them should be available online. Let me know if you have any questions or anything. The assignments are great. Again, there are a few things in your assignments or your grade related to your grading. One of them, your participation. So basically, usually it's in class and out class exercise, online, and a discussion that we might have, giving our time here. But yeah, so this is basically your participation. If you're trying to participate online, you can ask me questions with Zoom if you're kind of live zooming in. If you're doing something offline, you should be able to email me with any questions that you have. We will have two exams, one midterm and one final, which are 15% of your grade each. I am thinking about, at least contemplating about having online midterm or take-home midterm and take-home final due to the current circumstances that we have. Traditionally, the midterm and final would be in class, but I'll get back to you about the format. But they will be most likely online to accommodate other students and to increase accessibility to this course. Class project presentations, again, this have been having students present a chapter of the book, which you will be working with me, or I guess at least meeting with me to discuss what you want to do. This will be done in conjunction with other people in the class, so you will have a group of students and you will get together into your groups, and you will select a project that you would like to present. We will talk about this a bit more later on in the semester, but just be aware of that. Homework assignments, again, I view homework assignments as the main key method for you to learn. So, and to do this is kind of give you a bit more homework exercises, and because of that, I'm giving this 50% of your grade. Again, do your homework, try to understand what you're trying to do in the homework, and you should be okay. I think you should schedule periodic meetings with me to discuss your project and presentations. This project and presentation will be done in groups. And I guess you don't have to do periodic meeting with me until a month or so into the semester, because right now I will really focus on learning the class materials, and later on you can think about what kind of course you want to do. A lot of the time, what we did in the previous semester is that a student would select, or a group of students would select a particular chapter in the book that I didn't cover in the course, and they would present it, and they would implement it, and they would do a write-up about it. Again, these are some of the requirements about the projects and the presentations. And again, you don't have to schedule by monthly meeting with me until the second month, but I would suggest you to do that as soon as you can. At least try to get a group of people together and work on the project together. Homework, I think you should do the homework by yourself, but if you have to collaborate with other students, let me know. I mean, at least put the name in of who you discuss the homework problem with, so that I can keep track of who you are working with in your together. Here's your final grade. Basically, these are the standard scale other people use. You might have seen this before. So A plus would be between 197, 97 to 94, etc. So I think you should be okay. Do your work, and you should be okay. Here are some of the statement in the syllabus. So everything is kind of standard except the new thing they are doing this year. So there's a new face covering policy, university policy, that basically require the student to use face covering, I guess, alternatives or tools when you're on campus, when you're learning. So in particular, what it means that you come to class in person, you have to wear a face mask or a face covering. Like, it doesn't have to be face mask, it's something that have to cover your face. You can look at the definition more online, but this is the requirements. I will try to get, if you forget your face mask, I will try to get you some. I mean, I will try to bring some for you to use, but I cannot guarantee that I will have some additional face masks available. So I would strongly encourage you to bring your own face mask to class and wear them during class. I think you have to try out which one fit you the best. I was using one that's kind of tightly tight to my face, made by a different company, and it kind of made me uncomfortable. So I ended up switching to the UNL engineering one, which fit me a little bit better. So you just have to try out to see which one is better for you. So anyway, so you can read more about this. Attendance policy, I think I expect you to attend the class either online or in person. So this will be required. If you're concerned that you want to talk to the people in the department, there's like a form that you can use to voice your concerns about any particular problem. There's an email policy. As a student, you should check your email regularly, maybe a few times a day, maybe one in the morning, one in the afternoon, one in the evening, just to keep track of important announcements, especially we're doing a lot of these virtually or in person for some of you. Again, academic honesty, this is very important. You should do your own work. If you don't copy and paste work from elsewhere. If you collaborate with other people, I think it's okay to collaborate, but you don't copy your statement directly, right? You don't work. I mean, you have to specify, who you collaborate with, and to what degree. As long as you're document that, then I think it should be fine. But again, at the end of the day, you should do a lot of this stuff by yourself. There's also a CSE Resource Center. There's a Student Research Center in AB 112. So typically, the Resource Center was done in person in the previous year, but there's an update for this semester, in particular this semester, perhaps and beyond. So they will be doing a virtual student resource center. Basically, your students will be able to you will have access to online student resources center, and I think if you sign in, you should be able to see a bunch of some of the virtual. You'll be able to enroll in the virtual student resource center. If you have some disabilities or you have some problem, let me know. There's a center for that. There's a writing center, which you know. There's academic support service if you have if you're first year student or transitional students, my plan, you can use this opportunity. There's a counseling and psychological services you can take advantage of, especially some of the well-being during this time. Classroom comments, I'm open to discussing topics. I don't expect we will have a lot of controversial here. If you do, I'm open to your opinions regarding to the class topics. Video audio taping. So again, the class will be recorded, will be uploaded to YouTube so that we can share it to all the students here that are taking this class either remotely or in person, or either for your additional information. If you want to record the class additionally, please let me know. You should be able to do that if you want to. Academic honesty, again, as I told you, is an important thing. I would like you to do your work by yourself, unless specified, unless I specify it, and just to be academic honest. Right? Diversity inclusion, again, we welcome any groups or population here, regardless of their orientation, regardless of their ethnicities and their beliefs. Trespassing policy, I don't believe that, I'm okay with people attending my course. I'm hopefully there won't be any, individual that trespass my course, but in general I'm open for people to stay in my course as long as we have enough capacity. So because of the COVID-19 situations, we are capping the capacity to be roughly 1/3 of the original sizes. So here in this classroom, AV119, we have exactly roughly 15 to 16 seats available for students. So this is good because we only have roughly 15 people signed for the course, and some of them gonna be accessing the class online. So anyway, this is the syllabus. If you have any questions, let me know. And the lecture list, this is what we're gonna do each day. So I would think that we will follow the structure of this pretty faithfully. I don't expect anything to be changed unless there's other cancel days or anything like that. But I will expect to be here Monday, Wednesday, Friday myself, including and recording the video. Again, I will upload all the videos and lectures online, so you can take a look. If you have any other questions, let me know. Homework will be posted on this webpage. So I created one for homework 1. I haven't uploaded anything yet, but I will upload it after the second lecture. So here's the, I created this FAQ just in case you have any questions that you want to ask me, and I can post it for other people just in case. Group project, presentation rubric, I can go over them later, but these are kind of related to the 10% of your grade that I talked about earlier, right? So earlier I told you about group projects or things of that nature. So these are kind of related to them. So again, like everything will be uploaded on this webpage. Except the presentation and video, I will post it online. I would post it on Canvas so you can look at. The video will be available on YouTube. Again, I will post you the link so you can take a look each day after the lecture. So if you have any questions, let me know. So this is the general structure of the course. Yeah. So again, so this is pretty much it about the course structure. If you have any question, let me know. Oh, by the way, we do have an undergraduate TA for this course. Do you want to introduce yourself? So we have a TA, undergraduate TA, and
Hi, I'm Serene. Yeah,
so Serene took the course last semester. He was sitting in the corner right there. I still remember each lecture, and he will be TAing for my course. So for addressing some of your questions about the course, in additional to my help, and as well as grading some of your homework. And your owl is going to be available on the website later on. Right? So I will post his TA hours online. Okay, so let's go back the viewing. So I will just give you some of the brief reviewing of data structure and algorithm. A lot of these you should hear about before. If you don't, it's okay. I will talk about this a bit more as class progress. But for the remaining time that I have, which is like 20 minutes left, I will just briefly talk about some of the stuff in algorithm data structure that you've seen before. So going back to the example we saw in the introduction, we look at three type of examples: sorting, storage path, and matching. Right. So these are the three problems that we look at. So in all of these problems, we should have some input, output, and some algorithm doing it. Right. So as I said before, in a particular algorithm problem, you have a problem that you want to solve. You have some input to the problem, or input of the problems, and an output of the problem. Right? What are you trying to produce? And in each one on these examples that we look at, there's a particular input and output and algorithms. So could you identify some of them here? So if you want to think about it before you move on, you can pause here. Otherwise, I want to give you some examples. So in this case, the input would be what? A list of cars, right? And the prices or something. And the algorithm, again, they are the sorting algorithms that you know, right? Insertion sort, bubble sort, quick sort, any sort you can think about. And the output is sorted price, right, of the car, or sorted array, right? What about in this case? Well, here the input could be what? So input here is a graph, which we're gonna see a little bit later on. So you can create a graph, a weighted graph, where you have different points and different routes, and they're connected by some weight. So weight could be something like how far the kilometers, right, or the miles, right, from one checkpoint to another, right, so that you can. And what's the output? Well, output will be a path, right, to get there the fastest. And there's some algorithm that we're gonna learn how to use this to solve this problem. Here's the matching algorithms. What do you think the input could be? Well, the input could be this sequence, right? And also the matching sequence that you're interested in looking at. So what's going to happen is that you want to design an algorithm that sort of identify the subsequent and match this sequence, right? So the algorithm will be doing this, right? So the output again would be something like the positions of where these things would be, right? Of the matching subsequence. So at the end of the day, so how do we design algorithms? So this is the main topic in this course that we're going to try to address. So the first is you should understand the problem itself. You should try to say, okay, what are you trying to do, right? What is the input, what's the output? This is an important question. If you don't know what the problem is trying to do, then you're not going to be able to design an algorithm to solve it, right? So you need to know what it is. The second thing is what's your requirement? Do you want an algorithm to give you an exact solution, or an algorithm that gave you like approximate solutions, right? Solutions that might not solve the problem exactly, but it's close enough, right? We're going to talk about it a little bit later on, maybe near at the end of the semester, the notion of approximations, right? So in particularly, there's some trade-off in some cases in terms of the time, running time of the algorithm, and the solution quality. And also what are some of the techniques, right, that we can use to design algorithms for a particular problem that we're interested in. So in this class, we're going to talk about algorithmic design techniques. We also going to think about how to combine data structures and algorithms together to solve some particular problems. The second thing is that once we have the algorithm that we think about in our head, right, we might want to think about, okay, how do we concretely design an algorithm, right? How do we write it out? So some of you already done this already. Some of you have an idea, you write it out as a pseudocode, right? And then you implement it on your computer. There's another way of, and then all of this, once you design an algorithm, you need to think about, okay, whether this is correct or not, right? Some of you might have done this before, some of you might not. So this is not a main emphasis of this course, but we will talk about how to prove an algorithm correctly briefly earlier this semester. And given an algorithm, you want to analyze it. So analyze it here in terms of what's the running time of the algorithms, right? How fast does it run? How much memory does it use? What's the space complexity? What's the time complexity of particular algorithms, right? In particular, we want to say maybe whether this algorithm is correct or not. Right? Coding an algorithm, which you have done in the past, a lot of the time you might not write a pseudocode, you might just skip to writing the algorithm. So you will do some of that in this class. So here are some of the data structure that you have seen in the past. So there's three main data structures you've seen. Array, right, is contiguous chunks of memory where you can index an element using a basic operations. Linked list, here you have a element and a pointer that points to the next one on the list. Right, so this is something that you learned before. Double linked list is similar idea, but you have a back pointer for your elements and a front pointer for your elements. And there's two other concepts that can be implemented using some of these data structures, stack and queue. So do you guys remember what stack and queue is? Or queue is? If you don't remember, it's okay. Think about it. And if you want to think about it before you move on, you can pause here. If not, then you can move on. Well, I guess I want to talk about it. So stack, known as last in first out. So basically, you push it down, right? Whatever you put in the first, right? Then put in the last is gonna come out, right? So when I was making this slide earlier today, I was thinking about this analogy about this candy thing, right? I don't know how many of you have seen this, but there's like a PZ candy thing. So basically, what happens is that the top part of the candy will come out first, right? When you pop this thing, so you eat this first candy first, and then you move on to eat the second candy. So I don't know. Maybe this is just what I'm thinking about it in terms of defining what a stack is. Queue again is somewhat opposite, right? Well, not completely opposite, but basically it's first in, first out. So basically you have an operation where you in-queue something right at the end, and then you de-queue something in the front, right? So these should be a concept that you should know. If not, it's okay to revisit them if you have time. Also, we look at graphs in the previous courses. So graphs is another data structure that's very important in the computer science community and in our community. And basically, suppose that you have a graph like this, how do you represent it using computer, right? Or internally in your algorithms or in the computational tools that you have. Right, so there's two main ways of representing graphs. One is using adjacency list, and the other is adjacency matrix. Right? Do you guys remember what it is? If not, it's okay. So adjacency matrix is basically like a binary matrix, right? And adjacency list is like a linked list type of scenario. What time is it? Do you know?
1:16.
Okay. So let me kind of wrap it up very quickly, so I only have 1 minute left. So here in the adjacency, and this is adjacency matrix. So basically, it's a n by n matrix. Basically, it's the number of nodes by the number of nodes. Yeah, it's all zero except where you have something pointing to another one. So for instance, in the above graph, you have A pointing to C, or A is connected to C. So that means that A and C in this entry has a value of 1, right? And C and A has an entry of 1. So this is this is an indirect representation of the graph here. And you can also represent it as a list. So you have here you have like a array, you can think about it, or a list, right? And then you have A kind of point to C and point to D. So basically it store which one's adjacent to A, right? And given the graph that we have here, right? You can also do a similar representation for direct graph, but now the direct graph, you're not going to have this something like AC and CA. So basically, a direct graph basically says that if A points to another element here, then that would be a 1 on the entry. So this is an example. There's other things that we're going to talk about in the course: trees, sets, and dictionary. Trees is a special case of a graph representation where you have n-1 vertices and most n-1 vertices, n-1 edges when you have n vertices in a tree, right? But anyway, we're going to talk about that later on. Sets and dictionary, we're going to talk about them again later on in the semester. You can review this in the chapter 1 of the book. So this is kind of designed to test your understanding. I'm not going to talk about this too much, but if you're interested in it, before you move on, you can think about how to do these exercises. You can pause and try to check your understanding, but these are fairly straightforward to do. And again, this is another one about to see if you understand the graph or not. This is kind of intended for your exercise, so you can pause here and try to figure out what they are, and we can talk about this next class if you have questions. And you can think about what they look like. So the last thing is the in-class exercises. Again, we don't have that lecture right now, but I do have a couple questions I want you to think about before I end today. So the first thing is, well, I kind of want you to give me your information. So if you're watching this video, maybe it's a good idea to send me an email telling me about these information I gave you. So here, usually I gave people a problem in class. Like this is like algorithmic puzzles that would be interesting to look at. So you can take a look here. I'm not going to read this here because I'm kind of running out of time. But if you're looking at this video, look at this problem and think about potential solutions. And particularly, I'm going to put this on your homework, so it would be good for you to think about what potential solution this would be. The second question is this question about designing an algorithm for checking whether two different words are anagrams. So this again will be part of your homework. I will put up there later on in the week. But it'd be good for you to think about this, right? So this is pretty much it for today's class, and I welcome any questions that you have.